Hello, everyone. Welcome to our webinar. This session will be recorded for the people who were not able to attend at this time, but definitely want to see what we have prepared for today. Feel free to address questions during the presentation in the chat or just note them down for our Q&A section at the end of the presentation. This webinar will continue our research started in our previous webinars for using AI in supporting development activities. In our previous webinars, we looked on how Gen AI can speed up the development process by being able to generate code and being able to generate unit tests. Today, we'll make a step forward and we'll try to discover how useful the AI is in knowledge transfer and becoming a true assistant for both the developers and the business users. A couple of words about ourselves. My name is Mihai Nagoe, and I'm an operations manager within Wayfair. I started in 2013, and I have together with me one of our tech leads, George, who worked on this research project that we call ChatOE. George, do you want to add a couple of words about yourself?
Hi, I'm George, tech lead at Wayfair. It focuses web and mobile technologies and recently AI. As Mihai mentioned, I also was part of the team that built the small app we're going to demo. Mihai?
Thank you, George. Couple of words about Wayfair. We started in 2012. We have over 13 years of experience providing reliable services and solutions. Our team has grown steadily and now includes more than 100 skilled professionals. Over the years, we have built strong, lasting partnerships, with some lasting more than 11 years. Our longest partnership shows the trust and value we deliver. So far, we have worked with over 50 happy customers, and 19 of them still work with us on current projects. This shows our commitment to building long-term relationships. We offer services like modernization, maintenance and support, quality assurance, consulting, and project delivery. Our talented development team stands out because we hire top graduates from leading computer science universities, mixing their new ideas with the skills and experience of our seasoned professionals. Our primary technologies center on Progress OpenEdge and web technologies. A significant portion of our projects focuses on modernizing from Progress UI to web technologies, with Angular and React being the most favored options. We have experience in developing desktop, web, and mobile applications using various frameworks, including low-code and no-code solutions across different environments. Additionally, we offer UI/UX design services, support for DevOps, including continuous integration and continuous delivery implementations, and both manual and automated testing services. We are located in Cluj-Napoca, the major city in Transylvania, northwest part of Romania. As an interesting fact about Cluj-Napoca, besides building the largest AI research center in Eastern Europe, in 2025, Cluj-Napoca's top IT universities are launching AI-powered programs that let students build real startups before graduation. Some even land funding while still in class. It's where education meets leadership in real time. This is the agenda for today. We will discuss concepts related to RAG, Retrieval-Augmented Generation, benefits of using it, an introduction to vector databases, and a short demo on our ChatOE tool. What is ChatOE? Well, ChatOE is a specialized AI assistant designed to support developers working with Progress OpenEdge. Built on top of OpenAI's models, it is enhanced with domain-specific knowledge and designed to support developers by answering questions and generating simple code. ChatOE exemplifies how RAG, Retrieval-Augmented Generation, can be applied in a real-world software development environment. By combining retrieval from curated OpenEdge documentation with internal project source code and powerful language generation, it offers precise answers to developers' questions, bridging the gap between traditional search and intelligent assistance. Of course, there are some limitations. While ChatOE excels at understanding and answering questions related to OpenEdge technologies, its focus is on knowledge assistant, rather than full code generation. This makes it ideal for reducing lookup time for documentation and syntax, providing support for developers. Before jumping into the tool, we need to cover some of the concepts. RAG, Retrieval-Augmented Generation, improves large language models, LLMs, by incorporating information retrieval before generating responses. Unlike traditional LLMs that rely on static training data, RAG pulls relevant text from databases, uploaded documents, or web sources. RAG also reduces the need for users to continuously train the model on new data and update its parameters as conditions evolve. In this way, RAG can lower the computational and financial cost of running LLM-powered chatbots in an enterprise setting. The typical RAG setup uses a vector database for embedding-based retrieval. Documents data are first turned into embeddings at system setup time. Then, when user prompts, user query is also embedded. The nearest vector match is retrieved, and finally content is injected into the prompt. This is the setup that we also have for ChatOE. These are the stages for Raki. We have indexing. Before any question is asked, reference data like documents or knowledge graphs is converted into embeddings, numerical representations of meaning. These embeddings are stored in a vector database, making it easy to search for relevant content later. It works with unstructured data, text, semi-structured data, tables, or structured graph data. Retrieval. When a user submits a query, the system searches the vector database to find the most relevant documents. This step compares the user's query, also converting to an embedding to the indexed data. Augmentation. The system adds the retrieved document to the original along user query, forming an augmented prompt. This helps the model understand not just the question, but also the relevant background information. Generation. The large language model now processes the augmented query and generates a tailored response. Some systems add an extra step like re-ranking results, selecting better context, or applying fine-tuning to improve the final answer. Here is a small diagram of RAG process, and you can see there is a separation between setup time and query or prompt time. How RAG works: let's start with a user question. You ask something, for example, how do I create an OpenEdge procedure? Turn the question into numbers. These are embeddings. Both your question and a collection of reference documents are transformed into vectors, a way for the AI to understand meaning. Search for the relevant info. The system compares your question's vector with the document vectors in a vector database and finds the most relevant chunks of text. Build a smart prompt, that's the augmentation. These chunks are added to your question to create an augmented query, something like answer this question based on chunk 1, chunk 2, chunk 3. Then generate the final answer. The language model uses this enriched input to produce a context-aware, accurate response grounded in the most relevant information available, even if that information wasn't in the original training data of the model. Benefits of RAG. Some of the benefits using Retrieval-Augmented Generation are cost-effective implementation. This avoids the high cost of retraining large language models, enables easy integration of new domain-specific data into generative AI systems using retrieval rather than fine-tuning, access to current information, improved user trust, and greater developer control. These are some generic issues with LLMs, like hallucination, outdated knowledge, generic or vague answers, incorrect interpretations, or lack of transparency of source data. RAG can improve this by retrieving real-time, trusted information from known sources, improve the accuracy of the response, and provide control for the organization, and have a clear source visibility. What is a vector database? Well, a vector database stores, manages, and indexes high-dimensional vector data. Data points are stored as arrays of numbers called vectors, which are clustered based on similarity. The design enables low latency queries, making it ideal for AI applications. Okay, let's start with what a tensor is. Well, a tensor is simply a structured collection of numbers used to represent data in machine learning and AI. What are vectors? Vectors are ordered lists of numbers that represent data in a way machines can understand. They're a special type of tensor used in machine learning to describe and process information. Key concepts: a scalar is a zero-dimensional tensor containing a single number. A vector is a one-dimensional tensor containing multiple scalars of the same type of data, and so on. Vectors let AI system represent complex things like text, images, and sound in a format they can process and compare. Text, words, and sentences are turned into vectors so chatbots can understand language. Images, each pixel is a number combined into a high-dimensional vector to represent the whole image. Audio, sound waves are transformed into vectors, enabling speech recognition. What are vector embeddings? Well, these are numerical representations of data points that convert types of data, including non-mathematical data like words, audio, images, into arrays of numbers that machine learning models can process. We can think of an example like for cat and dog. These can be represented as three-dimensional vectors, and words with similar meanings or contexts are expected to have similar vector representations. For instance, the vectors for cat and dog are close together, reflecting their semantic relationship. Embedding models generate these vectors, and the vectors are stored in vector database to enable semantic search, recommendations, and generative tools like ChatGPT. Even if two words are spelled differently, car or vehicle, their vectors can reflect similar meanings, helping AI applications understand context, not just exact words. And we'll see also this applies to different languages. Usage of vector database. Vector databases are built to store, index, and search high-dimensional vectors efficiently, making them essential for fast and intelligent AI applications. Vector storage stores vector embeddings. These are outputs of AI models. Also stores metadata like titles or tags, which can be filtered in searches. Vector indexes make searches fast, even with millions of vectors. Vectors can be indexed by using algorithms. And similarity search based on querying or prompting. Vector databases are a popular way to power enterprise AI-based applications because they can deliver many benefits like speed and performance. Vector databases use various indexing techniques to enable faster searching. Vector indexing and distance calculation algorithms, such as nearest neighbor search, can help optimize performance when searching for relevant results across large data sets with millions, if not billions, of data points. One consideration is that vector databases provide approximate results. Applications require greater accuracy, and those might need to use a different kind of a database at the cost of a slower processing speed. And we have the other benefits like scalability, a lower cost of ownership, data management, and flexibility. These are some examples of vector databases available, each coming with different benefits. For our demonstration, we used the Pinecone, and one interesting example is PostgreSQL. Extensions like pgvector bring vector search to a familiar SQL environment. This is great for teams already using Postgres, but limited scalability for high-performance vector search tasks. About Pinecone. This is a fully managed cloud-native vector database designed to store, index, and search high-dimensional vector embeddings efficiently. It enables developers to build scalable, real-time applications that require semantic understanding, such as AI assistants, recommendation systems, and semantic search engines. What we'll see in the demo part is the integration of Pinecone to augment a large language model with domain-specific knowledge from Git source projects and documentation related to Progress OpenEdge technology. But that's the part that we'll cover on the demo side. There are some evaluation metrics of RAG to see how efficient it is. We have BLEU, bilingual evaluation understudy. BLEU checks how much overlap there is between the assistance response and the reference, which is the ideal response or ideal answer for that, by comparing short word sequences called n-grams. This is commonly used in translation and text generation tasks. If many word sequences match, the score is high. There are some limitations. It focuses on exact wording rather than meaning, so it may penalize valid paraphrases. Code BLEU, the logic is designed for evaluating code generation. Code BLEU blends traditional BLEU with code-specific checks like syntax, structure, and keywords. Why it's different? It understands that for code, correctness often depends on more than just matching tokens. Structure and semantics are also important. This is good for AI models that generate code or explain code logic. On our ChatOE application, we combined 3 core components: an n-gram match, which measures basic textual similarity like BLEU, a syntax match, estimates structural similarity, how code is organized, and keyword match focuses on correct usage of language-specific keywords like define, for each, and so on. Each of these components is assigned a weight. Example, 40% for n-gram, 30% for syntax, and 30% for keywords. And the final code BLEU score is a weighted average. This table is an output where we compare the performance of ChatOE and OpenAI, OpenAI only, on 3 OpenEdge related questions using 2 evaluation types: text score, semantic similarity of natural language; codebase score, accuracy of code generation, including syntax. Each score in the table is between 0 and 1. A score closer to 1 means better performance. A score closer to 0 means worse or less accurate output. And now we're on the interesting side of our webinar. We're going to do a short demo of ChatOE. And yeah, the stage is yours, Georgia.
Thank you. Share my screen first. Okay, let's start first by looking at the resources that we needed for ChatOE and that are standardly used with the RAG implementation. As Mihai has mentioned, we've used Pinecone as a vector database provider. You, of course, need first a Pinecone account and to create API keys to consume the REST API. Pinecone offers the possibility to create indexes. Important detail when creating an index is choosing the embedding model, because after creation you cannot update the embedding model with data inside, so you will be limited to embeddings created with this embedding model. For ChatOE, we created 2 indexes. We decided to separate the knowledge base in 2 indexes. One that stores OpenEdge documentation. So this a part of OpenEdge standard documentation in PDF format. We parsed, we chunked, and then stored in Pinecone index. We did the same for some of our internal GitLab repos by programmatically going through them via the REST API and the same parsing data, chunking, and storing the data in Pinecone. Let's look at an actual record. So this is how a record looks, and you can see the embedding the vector that Mihai specified. So this is the representation of the original data. Along with the vector value, you can add various metadata, whatever you want, basically. In almost all RAG implementations, one of the values that you will need is the original data that resulted in this vector. Also probably useful from what source file or the data came from, and whatever other metadata that you find relevant or useful at runtime. We also use OpenAI, which again, of course, you need first to create an account and obtain an API key. OpenAI provides a lot of functionality, and the REST API is large, it's extensive. We will focus now just on the parts that we used, and the part of the API that we used for ChatOE and for RAG, which is called completions. We also implemented, so to consume those and to make the integrations, we implemented a Node.js application with a small framework called Nest.js. For JavaScript, for Node.js specifically, both Pinecone and OpenAI offer dedicated SDKs, which are just wrappers on top of the REST API. So you can consume the API from with any REST client. It's of course a bit easier with the SDK from the two vendors. But the entire setup is not dependent on any of the vendors of the technologies. For both Pinecone and OpenAI can be replaced with other solutions, and the same for the JavaScript backend can be replaced with another technology. The only limitation is to be able to consume the REST APIs. Let's dive a bit deeper into the setup part. So before going to the prompts and at runtime, so Mihai mentioned that there is an initial setup phase, so populating the vectors, and a brief look. We will have to look at JavaScript code. So a brief look at how we did this, and I will focus on how we processed the Git files. So for each of our Git repos, we use the Git Labs REST API for this to programmatically access the files. We obtained the entire file contents. We then implemented a parser ourselves, which is just splitting OpenEdge files into methods and procedures and so on. After we obtain the chunks, we enhance them with the metadata that we need, and we store them into Pinecone. But we actually store the embedding. So as mentioned, the chunk, the text value is transformed into an embedding, and that embedding, along with metadata, is uploaded, offsetted into Pinecone. Okay, let's go now to see the actual app. So the app has the standard web interface for an AI system with the functionalities that are common for an AI assistant. It's implemented in Nest.js. Let's try prompt. also implements streaming. So OpenAI allows streaming of responses. You just have to make use of the streaming functionality in your backend and in your frontend. But we also implemented the streaming feature from OpenAI. What just happened? I executed the user entered a prompt. Let's look a bit also in step-by-step in code, the high-level flow of what you sampled. So the user entered a prompt. The prompt reached the backend. We obtained the previous conversation history. So by now I didn't have any conversation history, but for longer conversations, you might have previous messages. And one of the things that we do is we search the knowledge base, we call it, but it's basically querying Pinecone for in one of our indexes to see if there's relevant information. And how this is done, the actual user query is transformed into an embedding, and that embedding is then retrieved from Pinecone. We have some thresholds. What we decide is a useful information found in a Pinecone. We then do the same for code, and in the end, we call OpenAI with the enhanced prompt. This is basically our prompt enhancement. It contains a static part that only constrains the assistant, and the part that says, okay, I want the output in a certain format, and then the actual valuable part, what was found in the vector indexes. Okay, let's move back to the app. I'm not sure if Mihai mentioned, but the vectors and the embeddings are also language agnostic. So I put this prompt to the assistant. Let me try to put the same prompt in a different language, and I hope this is correct in Dutch. And the assistant should be able to also make the response. Yeah, demo time. That demo didn't work. Try one time. So I'm trying to ask the same question in Dutch, and hopefully the assistant responds in Dutch, and now it does. The last time it didn't. But the embeddings are language agnostic. They do not. They will when this prompt in Dutch is embedded. If similar information is found in the vectors, but it's in English, the similarity should still be there. And the chunks in the vector database should still be relevant for the prompt. Okay, let's do a small comparison between ChatOE and OpenAI. Since ChatOE is an assistant on top of OpenAI's models, enhanced with the RAG implementation, and ChatGPT is more or less straight up using OpenAI's models, though ChatGPT is also doing some extra stuff. But it's good enough for us to compare and to highlight a bit the impact of RAG. So I asked ChatGPT a question for time purposes before the demo, and I will try to do the same in ChatOE. So I asked ChatGPT to give me a hybrid realm implementation example in OpenEdge. If you don't know, hybrid realm is used in realizing authentication in OpenEdge REST APIs, or can be used for that. And ChatGPT's response at first glance looks relevant. But if you look closely and if you, for example, try to take this code and actually make use of it, these are non-existent things. They're just made up by the ChatGPT. So ChatGPT has some knowledge about OpenEdge syntax and how responses should look, but yeah, it doesn't actually have real knowledge about hybrid realm and a real example for this. Okay, let's try to ask this chat to read the same. Hopefully this demo works. And what we're hoping will happen is that the assistant, Chantoi, will access relevant information from GitLab repos in this case. And I personally know that there should be relevant information in our GitLab repo. So this is one of the files that was indexed in one of our GitLab repos, which is actually a hybrid realm implementation for authentication into an OpenEdge REST API. Let's check the response. And this time it's much more relevant. We can probably see that it's really close and relying heavily on what we have in our GitLab repo. But we can see straight up that, it does use correct interfaces. Also, the correct methods are implemented. So it might not be a complete response. It is an example. I asked for an example, but it's something that can get you going, and that's much more relevant than what ChatGPT responded. And it was done through accessing our custom knowledge from GitLab via the Pinecone index. Okay. Get a bit into evaluating the AI assistant. So this implementation has a lot of integrations and a lot of moving pieces, and we found it hard to evaluate if change to the system is useful or not. Are the responses better given by the assistant or not? So what we did in this direction was to implement a standard set of prompts with an expected answer. We separated the expected code as a separate value because you will see we try to evaluate it separately also. And for these prompts via a script where we run it when iterating on the app and evaluate if the app works better or worse. We find it useful to also do the same directly using only OpenAI to compare the basic OpenAI model versus our enhanced with RAG model or system. And first, we only did a cosine similarity comparison. So using the same a similar approach that the vector database uses to compare, okay, what the assistant or assistants, the ChatOE assistant and OpenAI responded versus the expected response. We noticed that this works okay when comparing text responses. So when there's plain text, this comparison style works okay. But once the response contains a lot of code, this comparison starts to not be relevant anymore. And we tried to implement a custom blur approach. This is a standard in comparing generated code and for other programming languages that there are robust and mature implementations. Unfortunately, there is none for OpenEdge. So we tried to start one or to make a basic implementation for OpenEdge. The big difference is that this comparison also tries to take into account OpenEdge code structure, syntax, keywords, because a lot of times two pieces of code might look similar, but they're actually not at all equal or yeah. What we did manage to do with this approach was at least for prompts where the response was, as you saw for ChatGPT, the hybrid realm example, at least when the assistant response has no relevance to the prompt, that is much better detected with this approach. But as I've said, this is an attempt to solve the benchmarking issue and actually evaluating AI systems. Okay, that is the demo.
Okay, if there are questions so far, or you want to take something in the demo part?
Hi, Micha here. Hi, George.
Hi.
I was a little bit curious about the cost, but I'm not sure if that's in this meeting or...
Well, you mean the cost of implementation
Using
or
this
the
tool.
cost of using the
Of
tool?
implementing this tool, or do you have
Yeah.
any clue? For example, if we would implement it here for our progress developers, what kind of cost do I need to take into account? I need a ChatGPT subscription, I presume.
Yeah. So if you follow the exact architecture and the exact tools that so you're not obligated to do so, there are options. By the way, one interesting option that is recently available is that OpenAI also now offers their own vector store. This wasn't the case 6 months ago. But with the exact tools that we used for the volume of data that I'm not sure if you grasped it or how much documents we indexed, the Pinecone costs were 0. So we didn't get out of the free tier. This has some downsides. So Pinecone does limit you a bit on the free tier, but we managed to implement this small app on the free tier with quite some volume of documents. On OpenAI, the costs for what we did are again small. By small, I mean for medium usage that we did when developer testing and with people from our company, only the RAG implementation, I think is somewhere around 10 euros a month. What does have large costs is actually training models. So we also made other attempts with these tools, and those do have larger costs involved. But specifically for what we showed now, the costs I would say are not big.
Maybe to summarize a bit, there are some fixed costs. The fixed costs are the one to set up the tool, like putting the vector database in place, loading your code base, loading your documentation in that vector database. That has a fixed cost based on the volume of the code base, the magnitude and the time that is needed. Probably that's I don't know, maybe 2 weeks, 3 weeks job to implement it. And then you have subscription cost for the number of the prompts and the number of for requests. So if the model is used more often, then there is a higher cost attached. But let's say for prompt, the costs are in the cents side.
Yeah, the costs are measured in tokens, and prompts can vary in size. But for just approximating here, so for let's say 100 users that use your assistant daily with 10 prompts, I think the cost would be at maximum $100 per month. But I'm averaging here. I think it could be even lower than this.
No, it's just to get an idea. But I'm also a little bit curious about, because you showed us and you tell it's about 2 to 3 weeks maybe to index your data, to make a kind of vector database of it. But what I was missing a little bit, because my experience on this is that you also have to explain the context. And how difficult is that, or is that also within that 2 or 3 weeks, or how do you see that? Because without the context, the system really doesn't understand anything.
Well,
please go on.
Yeah, the context is actually what is built in the vector database. So the context is generated by indexing all the data in the database, and there is a, let's say, static part that needs to be developed. And also this time frame of 2 to 3 weeks is to create the ecosystem, actually have the application hosted on your side, build that part of Node.js and JavaScript part, make the API key for OpenAI, and I think that's pretty much it. Once you have the tool itself is going to be hosted on your environment. It's not going to be part of other environment outside. You're going to have a web application in your environment that is going to build the context from a vector database that is going to hold your data.
Right.
Okay. Thank you for the question, George.
Yes, no problem.
I see another question is regarding privacy. What data is exposed, and what are the security measures that are taken?
This part, so both Pinecone and OpenAI offer industry standards for cloud computing. So your data is safe in transit and in all states. GDPR is followed for EU clients on demand. And regarding is your data used by the vendor itself? So is OpenAI training their next models on your data? The answer is no, based on the terms of service from OpenAI. So they do use what you enter in ChatGPT, so that for sure is used in training the next model. But if you're paying the subscription for the API, that data is yours. It is not used in any way by OpenAI, and the same for Pinecone. And other than this, they offer, both of them offer industry standards for cloud computing. So as safe as any other cloud vendor, big cloud vendor.
Okay. Another question is, why used Pinecone?
So the reason that we chosen Pinecone is that when we started this small project, we also tried to understand the ecosystem of it and the AI domain. And Pinecone is a mature solution for a vector database. And at the time, it was also suggested by OpenAI. So OpenAI, I think, offers the most user-friendly API and the most features. And at the time, they also suggested Pinecone for a vector database to pair. Now they do not. Everything related to Pinecone was removed from documentation. They now have their own vector store that they propose to use. It does have the value that you don't need two cloud vendors, but yeah, it's a bit more. They abstract a lot of the operations, which makes all the setup faster. But it's a trade-off. So you don't have management on the vector itself. Maybe you want to split the data yourself. So we chose Pinecone because it's mature and because OpenAI suggested it as a solution.
I have another question, if possible, if nobody else is, because I don't want to. For example, I know Fazil from your company. He's a great Progress developer. Does he also use? Do your own Progress developers also use this tool already? And what's their experience with that tool? That might also be interesting to add this to this webinar. And the other question I have is, can we get a copy of this webinar? Because I see you record it. So we get the link, I hope.
Yes,
yeah,
yes.
I'll answer the first. Yeah. Can I answer the first question?
You can do the long answer.
So the experience of developers with the tool is mixed. So I think the RAG approach we've managed to do it. The problem is for developers that ask random questions, a lot of times there is no useful knowledge in our code bases. So, and in the end, so for a lot of the user prompts, the answer is given purely by OpenAI, which, as you probably know, is not great. So the tool brings values when it finds useful information in our code bases, because most of the questions are relating to code. So what we saw from internal usage is that's the bulk of the questions. And what we also saw is that the answer is good for the user when we find relevant information in our repos, which doesn't happen that much if you let 50 developers ask random questions in our 6 small internal repos. So in that sense, yeah. Does this answer your question?
A bit, because there lies a question behind, of course. If I would be a customer of yours, I would say, well, that's very interesting that you have a tool. That means you can be hired productively. So one of the deals I would suggest then is, rather than work with 3, 4, 5, or 6 developers from your company, I would say first let them learn with Chat AI, put that in the price, and then hopefully we get developer quickly.
Yeah, we're not, and I think we are able to get to that state. I think the only company that can realize something like this is actually OpenEdge for this domain. So what we try to do is to find out what can be done with AI, implement RAG, and we applied it on our domain knowledge, right? So what can we do with RAG? Let's apply it in our daily work. We found that RAG is useful and that you can use it. The actually core problem so a generic OpenEdge developer helper is a bit too ambitious, I think, and something like this. So we tried also other approaches besides RAG, and I think to actually deliver on that promise, a real assistant, you need also a lot of resources, money, and more importantly, data. So data that you can leverage for the assistant, which we do not have. Yeah.
Thank you very much.
There's another question. In theory, can I have everything installed locally, my internal network, and without an internet connection?
You could. So for all the parts of the system, you do have on-premise solutions. We did not try them. So you could make a RAG implementation with an on-premise model, an on-premise vector database. And of course, the smaller backend can be installed on premise. But we did not try the specific solutions. We went with the big and popular vendors. But there is this possibility. Yes.
Okay, but I guess this limits the development of future models actually. So you would need to have the model installed locally on your premise.
Yeah.
Okay.
Can I have a question? I hope you can hear me
Shoot.
well.
Yeah.
Okay, it's half of a question. So right now in your demo, you showed about ChatOE somehow connected to the Progress OpenEdge knowledge, repositories, documentation, and all that. But in the end, you also showcased an approach, a technical approach. How can you index the documents and repositories and other dedicated sources from various domains, right? So for example, you can have like an ERP system with a user manual that you can ingest basically in the system using this approach. And then you can have like an interactive user manual for the end user or for your business analysts or for your internal users. Am I right? Or, yeah.
Yeah, you are right. So and first on specifically what you asked, you can use vector databases with any type of information. So we used OpenEdge documentation and code because that's what we had, and that's our business domain. So, but you can index anything that you can transform in raw text. You can even implement RAG without the vector. So there might be use cases where you want to augment information from a standard database. And you could even combine this. You could, for example, always augment a user prompt with his bio. Not sure why would you want that, but that's possible. And the bio can come from a standard database. Vector databases do come with a feature of fast similarity search. So that's their main draw, that you can put all types of information in there, and then you can search based on similarity. Did I answer with you?
Yes. Can I connect to Jira and Confluence and fetch my data from there?
You can connect to any the traditional data source if you have a connector. So if you have for these tools, I think they all have REST APIs like we use for GitLab. So doesn't really matter how you get the data as long as you can.
Là, on va lancer un appel de charge en urgence. Donc, on a tout contrôlé avec Armand.
So if you can get the data into text format via any type of connector, REST API, or any other means, then you can store it in a vector database. So the short answer is yes. The long answer, just.
Okay, and just my last question, I promise. In the conversations that the user has with the model, can you implement also like custom functions or some triggers based on some, I don't know, keywords or hints from the conversation itself?
Yes, you can. And we didn't demo this today, so we have also another assistant that actually has this implemented. So the models can determine that a function should be called. So if you define a set of functions, if you define, for example, that an email to an admin should be sent in case of something happening, or and the conversation with the user goes in this direction. So, for example, if in your app the user says this functionality is not working in your app's AI assistant, and you define that in these type of scenarios where something is not working in the app, a mail should be sent to a certain person, and you need to specify metadata for this. So you need to define a bit this functionality. What are the parameters? What's mandatory? What's not mandatory, and so on. The model can determine that a mail should be sent to the admin, and it signals this to you via the REST API. So the model does not make this call. It just says, it determines that, hey, in this conversation, you should probably send an email to the admin with this subject and this body. It's up to you to actually implement that call in whatever way you want, dynamic or not. But the answer is yes, and this is how we can do it.
Thank you.
Okay. Any other questions? Well, if there are any other questions, I see we're getting to our hour mark. Well, I hope the information presented was useful and answered some of your questions. If you have more questions, or you want to use an AI assistant in your projects, or you want to start the investigation on it, feel free to contact us by mail, webpage, social media. We'll be happy to support you. Thank you for joining, and see you in our next webinar.